Hello everyone. So we will be solving all the four problems of this LeetCode Weekly Contest 482. So let's quickly look at the first solution. So problem. Before jumping into the problems, I was trying to go live last day only, right? But I tried a lot, but it couldn't be happen. So the four solutions I recorded it, and I will be posting all of them in a single video. Please do like it. You have understood the problem statements and the solution as well. So let's look at the first problem. So the first problem says maximum score of a split. So what are they trying to say is you are given an array integer nums of length n. Choose an index I such that I is greater than 0 and less than n minus 1. And for a given chosen split, let the prefix sum be the sum from 0 till that ith index. So sum of 0 plus sum of 1, sum nums of 1 plus nums of I, and suffix minimum be the minimum value among value which is greater than I, which is nums of I plus 1, nums of I plus 2, dot 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 till nums of n minus 1. So score of split at index I is defined as prefix sum till that point minus suffix minimum, and you need to return the maximum score that you can achieve using this valid split indices, right? So I have made you understand all. I have already recorded the solutions in the copy, so we will look at the test case in the pen and paper with using pen and paper only. All right, let's look at the first test case which is given to us. The nums is given as 10, minus 1, 3, minus 4 and minus 5, right? So for this test case, we are allowed the best answer will be at I equal to 2, that is 0, 1, 2, 3 and 4, right? So if we pick at I equal to 2, right? So what are the condition given to us? The score of I will be prefix sum till ith index, prefix sum till ith index minus suffix minimum. So minimum after this 2th index, right? So if we look at this, the minimum will be minus 5. After this point, the minimum is minus 5, right? So and the prefix sum till this point will be 10 minus 1 plus 3, right? And the suffix minimum is minus 5, right? So ultimately it becomes 9 plus 2, 3, 12 plus 5, which is 17, and 17 was the best answer for this test case, right? All right. So if you look at the time constraints which was given to us, right? The time constraints was, let me focus a bit. Yes. So time constraint given to us was n will be till 10 to the power 5, right? So we need to write a solution which will work in big O of n or big O of n log n, right? So this was the expected time complexity. So for any problem, now first read the time constraints which are given to you. You don't for that, because you don't want to write a solution which will exceed the time limit, right? So you will have an idea that what solution would work here, right? So as you look, big O of n or big O of n log n would be needed, right? So first hint was pretty obvious that you need a p sum of I, right? So you already know how to find the p sum of I, right? If not, let's quickly look into it, right? Let's say the array was 10 minus 1, 3 minus 4 and minus 5. So how will the prefix sum array would look like? Prefix sum would look like 10. After this you will pick this index minus 1, 9. You will pick this index 12. You will pick this index 8. If you pick this index 3, right? So prefix sum array would look like this, right? And what we did, so prefix sum of ith index will be nothing but prefix sum of I minus 1 plus nums of I. So whatever was the sum till the previous index plus the sum plus the element which is at this current index, right? So prefix sum could be easily found by this, right? The main issue was to find the minimum element after this ith index, right? So how will you find the minimum element after this ith index, right? So for this, if you don't know, I am telling you a trick, right? So if you are told, right, to find any element which is minimum to its right side, right, then in that case what you need to do is you just need to traverse from the end of the array, right? So how will you traverse from the end of the array? You will start from, wait a second, yes, I hope this is now visible. So you will start from end. So the array is looking something like this at the beginning, right? You will start from end and keep storing the minimum element which was found to you, right? So at this point minimum is minus 5, right? And you will store it as mini, right? Mini is minus 5, right? and you will keep moving further, right? And you will see what is the minimum, right? I hope you know how to find minimum. The minimum of -4 and -5 will be -5 again. At this point also -5. At this point also -5. At this point also -5, right? So the mini array would look something like this, right? Now what are we said, what are we gonna do is just follow the instruction which was given to us in the problem, right? The problem said the score of I is the prefix sum till that point minus suffix minimum. So what we will do, we will find the prefix sum till this point, right? Prefix sum, wait, I will write it in the next page. It is 10 9 12 8 3, right? So prefix sum looks something like this. Prefix sum is 10 9 12 8 and 3, and the mini array was all -5, right? Every point it was -5, right? So let me quickly jot down these, right? Now what are they telling us is score of any index will be prefix sum at that point, and after this point means from the very next element, the minimum which you had, right? So if you pick up this element as your score, the score will be 10 and the minimum after this point. So you would not pick this one, don't do this mistake. The minimum after this point, so it will be -5. Even though it was also -5, still it was said that after, you can't have minimum at this point. Let's say it was any element which was minimum here. Let me take a small example so that you can understand it, right? Let's say it was -9 over here and -5 over here, so you won't pick this -9, right? You will pick element which is after this point, right? So it will become 10 minus 5, right? Prefix sum at this point will become 10 minus -5, which is +5, right? 9 minus -5, which will be 9 plus 5. 12 minus -5, so 12 plus 5. 8 minus -5, and 3 minus -5, right? So ultimately the maximum at, you can find all these values. It will be 14, it will be 17, it will be 13 and 8, and the maximum you need to return, so it will be 17. So I hope the intuition for this problem was pretty clear to you, and so that reason you will return a 17 at this point, right? So that was the code logic for this problem, and I hope if you see the code, it will be easily understandable. The things which I told over here will be done exactly in the code. And what is the time complexity of this problem? It is big of n, and we are using two vectors as prefix sum vector and a mini vector, right, to store the prefix sum and the mini. So it will be big of n and big of n. So ultimately space complexity is big of 2n, right? So it won't cause any problem to us. Now let's quickly jump into the code part and look how the code looks like. So let's quickly look at the code. I think if you have understood the logic, the code part, you should try it from your side. If you couldn't, I am there for you. So the code is, we are creating a vector called mini, right? And what I have said, we will start from the very end of the array, right? So minimum value is the last element of the array, and mini of n minus 1 is the minimum number which I have stored. From n minus 2 till the 0th index, we will simply update our minimum, right? And mini of I will be that mini num, right? So I hope this part will be clear to you, right? And after that, we are storing the prefix sum vector, right? Prefix sum of 0 is nums of 0. And after that, what we will do is prefix sum of I will be equal to prefix sum of I minus 1 plus nums of I, right? And after doing this, whatever I have told the logic, right, the value will be prefix sum of I minus mini of I plus 1, because we won't be picking up that element. We will be picking element which is after that element, right? After that ith index, right? So value will be that, and we are storing answer equal to max of answer comma val, and simply returning the answer. So I hope the code part was pretty obvious and clear to you. All right, so let's look into this second problem statement. So minimum cost to acquire required items. You are given 5 integers, cost 1, cost 2, cost both, need 1, need 2. So there are three types of items available. Type 1 items cost 1 and contributes 1 to the unit of type 1. Type 2 cost 2 rupees and contributes 1 unit to type 2. And item type 3 cost both and contributes 1 unit to both type and type 2. So you must collect enough items so that the total contribution towards type 1 is at least need 1, and total contribution towards type 2 is at least need 2. So you need to return the minimum possible total cost to achieve these requirements. So let's look at the test case first, then we will look at the code. So let's look at the first test case which was given to us. The first test case was cost 1 is 3, right? Cost 2 is 2 and cost of both is 1, right? Pardon me, need 1 is 3 and need 2 is 2, right? So the minimal cost to achieve all these need ones are something like this. I hope it is focusing on what is. Yes. So what we will do is we will first reduce both of these values by 2, right? So need 1 becomes 1, need 2 becomes 0, right? And to do this we will use cost both, right? And this will be 1 times 2, right? So the answer becomes 2, and still if you look, need 1 is left, right? After this we can again use cost both and make need 1 as 0, right? And need 2 becomes negative, but they have said that you can have at least need 1, means if it becomes negative it is not any problem to them, right? So cost both becomes 2 plus 1, which is 3, right? So this was the first test case. If you look at one more test case if you want, right? So if you look at, let's quickly look into one more test case. Cost 1 was 5, cost 2 was 4 and cost of both was 15, right? And need 1 was 2 and need 2 was 3, right? So what we will do is we will use this need 1 to buy the cost 1, right? Means cost 1 we will use all the type 1 operations, the type 1 values elements. We can buy it simply using the cost of 5. So it will be 5 times 2 and 3 times 4 plus 3 times 4. That will ultimately give us 10 plus 12, which is 22. Right? Now, why only these operations? Why are we changing our logic accordingly at every situation, right? So let's quickly understand a few things, right? Let's say whatever elements we are buying, right? Let's say the cost 1 was 4, right? And cost 2 was, let's say, 6. And if you buy cost both, right? Let's for a moment, let's take it 7, right? So tell me one thing, if cost 1 is 4 and cost 2 is 6, right? And if you sum these two elements, it is 10, right? So if you do individual, right? Individually, if you do these operations of reducing type 1 and type 2, then you will require like 4 for this one, 6 for this one. So operations might be a bit more time taking. Rather, if you use cost both, so like if I said reduce both by 1, for a moment, let's say need 1 and need 2 both were 1 only, right? So ultimate cost for, if you take these operations, the cost will be 10 rupees, right? And if you take these operations, the cost will be only 7 rupees. So which is better to use this 7, right? Because it is minimum, right? You need to return the minimum value, right? You need to spend less money. So 7 will be the minimum. So from this very statement, you can get an inference that if your cost both is less than cost 1 plus cost 2, or if it's all equal also, then also there is no problem. What we can do is reduce minimum values, at least reduce the value which are minimum. There might be a case like, see, 4 was there, right? So let's say need 1 was only 1 and need 2 was 2, right? So what you will understand from this is, let's say I'm leaving a space at this point so I can make you understand this if statement, right? So what I'm trying to say is, let's say cost 1 was 4, cost 2 was 6, need 1 was, let's say 1 and need 2 was 2. I'm taking smaller test case so that you can understand this more efficiently. So what I'm trying to say, if reduce the minimum value, right? Reduce the minimum need. Why? Because see, there might be a case where the cost of any type 1, cost 1 is only 4, right? And cost 2 is 6 and cost both is 7, right? So if you reduce this 1, it becomes 0, it becomes 1, right? And you spend 7 rupees, right? Now what you should do, should you reduce this need 1 which is left to you by 6 rupees, or should you spend 7 rupees? So you should definitely spend 6 rupees, right? You should not be going to cost both again, right? So that was my logic, that is, you should reduce the minimum need first, right? So what you will say is, cost, I'm finding cost both is minimum of need 1 comma need 2, right? Okay, after this we will reduce that, right? So answer will be plus equal to use both, which is this value, right? So I'm writing it as use both, not cost both, use. So use both into uh, use cost of both, right? I hope this is clear, that if it was 1 and it was 2, first reduce the minimum which is there, right? Because that will cost us a bit less, right? All right, so if we have done that, right, answer will be plus that, and need 1 will be reduced by use both, right? Need 1 minus equal to use both, and need 2 minus equal to use both, right? After this, what we will do, right? Let's look at a few more test cases to understand it, right? Let's say I had need 1. I'm taking a random test case now. Need 1 was 2, right? And cost 1 was, let's say, 5, and cost both was only 3 rupees, right? So which one should you use? Tell me. You should definitely use cost both, right? So the next condition becomes that if cost both is less than cost 1, then what you will do, you will simply add answer plus equal to, and if your need 1 is greater than 0, right? Need 1 is greater than 0 means if you have requirement of need 1, right? There is a requirement that you still need 1, then that simple answer will be answer plus equal to cost both into need 1, and need 1 becomes 0 because you won't again require need 1 value, you will make it 0 at this point, right? Similarly, you will do for cost 2. If cost 2 is greater than cost both, then you will simply reduce the value of need 2, right? Need 2 becomes 0 if this was the condition, right? And what the last test case is, if cost both is greater, right, than cost 1, or it is greater than cost 2, then you will simply reduce the remaining elements. Like small test case, let's take a small test case so that you can be so I am much more clear to you. Not, it won't be a bigger one, so don't worry for that, right? So let's say cost 1 was 3, right? Cost 2 was, let's say, 5, and cost of both was, let's say, 4, right? So, and I need 1 was let's say 2, and need 2 was, let's say, 3, right? So you will first see cost 1 is 3, cost 2 is 5, and using both is only 4 rupees. So why not reduce both of them? So minimum is 2, right? So you will first reduce 2 into 4, right? The answer will be plus equal to 2 into 4, which is 8, right? So you will first remove this to 0, this becomes 0 by reducing it by 2, this becomes 1 reducing it by 2, right? Now you have need 2 greater than 0, right? Need 2 is 1, need 1 is already 0, so you don't need to go again and check for it, right? You will write a code, but the logic is intended, I think it's clear, right? So need 2 is 1, right? And the value, so which one should you use? Should you use cost both, it is 4 rupees, or should you use cost 2, it is 5 rupees? Definitely you should use 4 rupees, right? This is the most greedy approach which should come to your mind. So you will use 4 rupees at this point, and your answer becomes 12. What if your need 1 was, let's say, 4, right? So after you have reduced this value, need 1 will still be there, so need 1 becomes 1. Let's say need 1 was 1 and cost 1 was 3, and cost both was 4 rupees. So now which one should you use? You should use 3 rupees. So answer becomes plus 3, right? So I have used all the test case, all the edge cases which were there. Let's quickly jump into the code part and understand the code. I hope the logic intended was clear to you. So I hope the logic is clear to you. That same logic we are implementing here. So use both is minimum of need 1 and need 2, and if cost both is less than cost 1 plus cost 2, we will simply increment our answer and decrement the need 1 and need 2 value, right? And if cost both is less than cost 1 and if need 1 is there, then answer will be simply cost both into need 1, and need 2 will be equal to, because see, if when you are again using cost both, then you are also reducing need 2, right? Means I hope, I guess this part wasn't clear to you when I was explaining it, right? So if let's say you had a value 2 in need 1, right, n1, and need 2 was let's say 3 left, right? So if you are again using cost both, then again you are reducing this need 1 and need 2, right? So if you're using cost both CB, right, so you're reducing and you are reducing this need 1, so need 2 will also be reduced at the very same point without using any extra cost, right? So that is what I am doing. Need 2 is also reduced by need 1, and need 1 becomes 0, right? Similarly we will do for same thing we were doing for cost 2 and need 2, right? And if need 1 is greater than 0, we will use the need 1 and cost 1 value, because cost both has not fulfill our need 1. And if need 2 is greater than 0, then again we will use cost 2, because cost both wasn't able to complete all the values using uh, cost both, and we will simply return the answer, right? I hope the logic is clear to you. So let's look at the third problem. Smallest all ones multiple. So we are given a positive integer k. Find the smallest integer n that is divisible by k, consisting of only digit 1. Right? So the number will be 1 1 1 1 triple 1 4 times 1. Right? This can be the number. Return an integer denoting the number of digits. So you need to return the length. You don't need to return the original n. Just simply need to return the length of that number. And why they are trying to say that you need to return the length, because you will see the n is still 10 to the power 5, right? So the length will be 10 to the power 5. The length can be 10 to the power 5. The number can't be stored in any data type. So that's the reason they have said you to return the length of this answer. Okay, so this problem's solution has a great mathematical proof to it, right? I will show you the mathematical proof as well and an example to justify what I'm trying to say. So the proof is, first look at this, right? What I'm trying to say is remainder of n is nothing but n modulo k, right? That is always true, right? Remainder is whatever the n value is with you have, and modulo k, right? Now what I'm trying to say is, let's say for n, let's call it a, right? Now if you wanted to find n a plus 1, right, what you meant over there is n of a into 10 plus 1, right? This is what you want to say, right? Let's say if 1 was there, so the next number will be 1 into 10 plus 1, right, which is 11. If the next number was 11 into 10 plus 1, which is 110 plus 1, which is 111. So NA can be written like this, yes or no, right? I hope it is visible, right? Yes. All right. Okay, so this statement is clear to you, right? Now let's take mod on both side. What will happen? n r of n a plus 1, n plus 1, rather I can write it as n plus 1, will be equal to n of a into 10 plus 1 modulo k, right? That is what remainder is. This is how we find the remainder, right? So this might be clear to you, right? Now what we can do is, this can be simplified as r of n plus 1 can be written as n of a, right? N of a modulo comes inside, so n of a modulo 10, right? Sorry, modulo k into 10 plus 1 modulo k, right? This is a classic modulos simplification, right? So any number which is a number, right, if you modulo this with an outer value, the mod comes in and the rest of the constant remains there as it is, and the modulo is still inside outside of this bracket, right? So if you didn't know, this is an example. If n of a, like I'm again writing the same part, modulo k, this modulo k will go to the number or the value which you had. So n of a modulo k, right, into 10 plus 1 modulo k. This value is same as this one, right? So r of, I hope this is visible, right? Yes. So r of n plus 1 is equal to n of a modulo k into 10 plus 1 modulo k, right? Now, so if you look at this part, right, n of a is nothing but n of a modulo k is r of n, right? So r of n plus 1 is r of n into 10 plus 1 modulo k, right? Now make this statement understandable to you. I hope this statement is understandable to you. So what we will do is we will tell this as new remainder, right? So new remainder is equal to old remainder, right, into 10 plus 1 modulo k. This can be written as this, right? Now the problem is over. Now I will make a few more observations to you so that everything is clear to you, right? Now first things first, let's say you had a 1 1, right? Or let's say you had any number 1 1 1 1 1. Tell me one thing, if your k was even number, is it even possible to divide that? Right, let me refresh it. Yes. So what have they said? That you need to find a smallest integer n which is divisible by this k. So any, because the last digit is 1 always, right? So any even number won't divide 1, right? 2 won't divide, 4 won't divide, 8 won't divide, and it won't because it has a factor of 2. So if 2 doesn't divide, 8 won't divide, right? I hope it is visible to you, right? Alright. So even won't divide. Will 5 divide this number? Any number n is 5 modulo n modulo 5. Will it be 0 any day? No, it won't be 0 any day, right? Because anything which has a 1 at the very end, 5 won't divide it, right? Alright, so these were the first assumptions from my side, right? I don't know if it's focusing well or not, but I hope it's clear to you, right? Alright, so first assumption is clear to you. Now let me make one more observation to you. The next observation is the cycle of k. Now what do I mean by this, right? Try to understand this. Any value, right, any n which you had, first of all try to understand this. You can't store the value of, why we can't brute? The first thought might come to you is, why can't we brute the approach? Why can't we just make the numbers, keep making it and store it in some value and simply modulo k it, right? You can't store a number which is 10 to the power 5 times long, right? You can't store 1 1 1 1 1 1 1 till 10 to the power 5. There is no data type to store this value. So that's the reason you can't store this number, right? If you could have stored this number in any form, then you don't need the remainder theory, but you can't store it. So that's why the remainder theorem comes to the place, right? Now what's the remainder theorem? What I'm trying to say is, let's take k equal to 7, right? So if you look at k equal to 7, right, and if you take the values, right, so values are 1, first value will be 1, then it will be 1 1, then it will be 1 1 1, right? So you can't store this in numbers, right? So that's the reason we will store the values of it in remainder, and I have proved it to you that new remainder can be written as old remainder into 10 plus 1. And if you observe this thing, right, if you know this thing, right, the remainder of any number is from 0 till k minus 1, right? If you modulo any value, like if let's say it was 4, so any number in the world, when you modulo it with 4, the values can be 0, it can be 1, it can be 2, it can be 3. It can't exceed this value. So for this reason, you can store this remainder in an integer or in a long, but as I remember, the key was still 10 to the power 5. So int is more than sufficient for us, right? All right. So what I'm trying to say was a cycle, right? What is a cycle of remainder, right? For any number, right, the values will repeat from 0. It can be in any order. That is not guaranteed that it will be 0, 1, 2, 3. If you go in a straight line, then the order will be in increasing order only. But if you are taking random values, because we are taking 1, then 1, 1, right, then 1, 1, 1. So for any values, this value will always be in a cycle. Value will be in a cycle. What do I mean? That if you got a 1, you got a 2, 0, 1, then you got, let's say, 3, then 4, then let's say 5. After this, if you have a cycle, means you got a 0, then again after some point you will get a 0, and this value will come, the cycle will be there in less than k moves, right? What do I mean by this is, if you have moved k times, right, if you have moved k times, then you might have repeated a value, right? For instance, let's take k equal to 7, right? For k equal to 7, if you look, I hope it is visible. Yes. So for k equal to 7, first let's take 1, right, and find the remainder. So old remainder is 1 modulo 7, which is 7, right? My hands are freezing a bit because it's too cold out here, right? So 1 modulo 7 is 1. Sorry for that, right? Now the next number will be 1, 1, right? Now if you look, I am writing at this point 11 modulo 7 is 4, right? Now how will this old remainder find this? What we have said, the new remainder will be nothing but old remainder, right, into 10 plus 1 modulo k, right? I hope you remember the formula which we derived in the last page, right? So old remainder was 1 into 10 plus 1 modulo k, which is 11 modulo k, which is 4. Alright, you would say that a number was also 11, you found an 11, so that's the reason you got the answer, right? Okay, let's move to the next part. 111 modulo 7, right? It will be 11 means 7, 7, you got a 4 in hands, 441, 35, so it will be 6 if I'm not wrong. So new remainder will be, old remainder was 4, so 4 into 10 plus 1 modulo k, right? 4 into 10, 40 plus 1, 41 modulo k, right? So it will be 6, right? So I hope this thing makes you a proof that our formula was correct, right? Now, sorry for that. Now what I'm trying to say is, if you keep moving this k times, right, for any number, if you keep moving for k times, you will definitely have the values repeated for sure, right? Means the value would be either 1, 2, 3. There might be a possibility that you don't get a 0. There might be a possibility, but after k times, if you don't get a 0, then that is for sure that you won't get a 0 in future as well. So this is a guaranteed proof of cycle in remainders, right? So if you have run the multiple of any value, right, let's say you had a 4, right? Let's take a small case now. K was 4, right? So for any number, let's take from 9 till 13. If you look, right, so for 9 modulo 4 is 1, 10 modulo is 2, 11 3, 12 0, 11 13 again 1. So see, the values have repeated in an interval of k. There won't be any possibility, there was never a possibility that this one will come after this value, right? Means there won't be a possibility that 13 and 14 you will get 1 over at this point, right? You will get 1 before this k ends, right? So if you don't get a value, means if you don't get a modulo 0 in k time, then you will never get. That is the proof. That is a simple proof that I'm trying to say. So I hope the logic is clear. We need to run k times, right? We will run k times. We have simply found the remainder idea, right? New remainder will be old remainder into 10 plus 1 modulo k, right? And if this new remainder is equal to 0, then you will return the length, whatever that you need to return the length, if I'm not wrong, right? Yes, we need to return the length. So we simply store an integer which is storing our length, and we will keep incrementing the length as well, right? And we will simply return the length. And if we haven't returned any value, we will simply return a -1. That if in k time if you didn't get an answer, you will never get the answer, right? So for the last test case we saw, for 111 k's value, the remainder was 6, right? Let's look it at more closely. Let's find the answer for this, k equal to 7, right? So if it was 1111, right? So new remainder will be 6 into 10 plus 1 modulo 7, right? So 61 modulo 7, which is 56. 56 means 5, right? All right. So again, new remainder will be 5 times 10 plus 1 modulo 7, right? Which is equal to 51 modulo 7, which will be 2, right? And the number would be 11111, right? Okay. So then next number will be, new remainder will be 2 times 10 plus 1 modulo 7, which will be equal to 21 modulo 7, and now the remainder is 0, and now we have found the answer. We will simply break out of this loop. So, and we will be storing the length, right? So we will return the length whichever is there to the, and that will be our answer, right? So I hope it is clear, right? Let's look at the code. The code is also pretty same, right? If k modulo 2 is equal to 0 or k modulo 5 is equal to 0, you simply return a -1. Old remainder is 1 modulo k. If old remainder is equal to 0, you simply return 1, right? Int length equal to 1, right? Because we have already stored the first value, right? 1 is already of length 1, so length starts from 1. We will traverse from 1 till 5, and length is incremented first, and new remainder will be found by the formula which I have told you, that is old remainder times 10 plus 1 modulo k. And if old remainder is equal to 0, you will simply return the length, right? And you will update your old remainder to the new remainder which you found this point, right? And if you don't return an answer till running till k, right, then answer is not possible for that number, so you will return a -1. I hope this part is also clear to you. The last problem of this contest, the number of balanced integers in a range. You are given two integers low and high. An integer is called balance if satisfies the both conditions. What is the condition? The condition is the length of the digit is at least 2, the length should be 2, and the sum of digits at even position is equal to sum of digit at odd position. Return an integer representing the number of balanced integer in the range low and high, both inclusive. So you will be given low and high, and you need to return all the balanced number which are at that point. All right, so let's understand with the test case. Okay, so let's look at an example for this. Right, low was given to us as 1 and high was given to us as 100, right? So what are the possible balanced numbers? The balanced number are 11, 22, 33, 44, 55, 66, 77, 88 and 99. And if you look at the even and odd indices, the sum are always same for these elements: 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. Sorry, not 10, 10, 5, 5 and all. So the sum at even positions, even and odd positions are same, right? The first condition is fulfilled, and their length is always greater than equal to 2, right? So I hope the example, the test case is clear. If you look at one more test case, 120 and 129, the only possible value is 121, right? Because the sum at the even position 0, 1, 2 is 2, and sum at odd position is 2. So that is why it is balanced, right? Alright, so for solving this problem, first of all you should look I have said earlier in this video as well that you should look at the time constraints. So time constraints was given as high could be as high as 10 to the power 15, right? So whenever you get something like this, first I have said earlier as well, but you should be awakened that alright, if the high is till 10 to the power 15, either it will be a maths problem, maths or greedy problem, which will work in lieu of 1, or you need to move to digit dp, right? So this I hope it was visible in camera, sorry. Yes, so I hope in this time constraint these two will be used, right? So this problem will be solved using digit dp, right? So if you don't know about digit dp, do let me know in the comments. I will make a detailed video about all the topic which are needed for this problem. Few things are needed, right? So whenever we are solving a digit dp problem now, two things are compulsory. Like there are multiple ways to solve, but whenever I solve a problem, I try to keep things very simple, right? First thing fixed is index, and second thing fixed is type, right? So I will explain each and every part which will come to our case, right? So first of all, what is logic at this point? So whenever, let's say, you had a value called let's say low was 120, right, and high was 129, which was given to us in a test case, right? So what we will do is we will find all the numbers from 0 till the low point, right? Let's call it x, and from 0 till high point, let's call it y, right? So what will be my answer is, this answer will be only my answer, right, from this low to high, right? So what does digit dp do? This digit dp's function will find us the answer for x, find us the answer for y, and our answer will be y minus x. That's it, right? Now how will you find that, right? So index represents that which see 10 to the power 15, first you will convert the number into string, right, and simply move in the string, right? Now let's say we had 120, right? So we will start finding from 0 till 120, and how we will find it? The index will be the, let's say at this point, you are at this point, so index represents this value, right? Type represents that can you take that the value above than that or lower than that, right? So let's say your type was 0, right? If type is 0, that means you have no restrictions, you can pick any value, right? You have no restrictions. Let's say you had, let's say 456, right? You were at this index, and you, let's say you formed a number called 3, right, and your type was 0. Then this means you can pick any value at this point, and the value will be, can be anything. Let's say you had a 9 over here, right? So if your type was 0, then you can pick any value irrespective of this value, right? Means, see, if you had a 3 over there and your type was 0, you can pick 9, right? And now you have no restriction, and for the next number, let's say you had a restriction, your type was 1. So if your type was 1, so you can't pick any value which is greater than 4, right? So you can pick either 0, you can pick 1, 2, 3, or you can you pick 4? That depends on type, right? So these three numbers are for sure possible to you, so you can pick any number, and that is what this type represent, right? So first two constraints are clear to you. Now the next thing is started, right? This is also a thing I have noticed that many answers get a bit deviated because if you have not used a started. What does this started represent? Let's say you have created number 0000, right? So this isn't a number, right? This is almost equivalent to 00, right? So started represents simply that value which has already begun. Let's 001 is started, right? The started value will be alright at this point, right? So my DPs, what are the changing state? The first state was index, second was type, third was started, right? The next will be length, right? Length is also had a constraint that length should be greater than equal to 2. So why not just store it, right? Length is also stored, right? And one last thing is difference. Now why are we using difference? Because we need to find the sum at even indices and the sum at odd indices as well. So we are creating a difference, right? What will be the size of that difference? Let's say you picked all elements which were even, right? And So we will have, like, let's say the length was 15, right? So for 15 you will have 9 indices which will have even, or let's say 8 indices which will have even. 8 or 9 you can pick up any higher value, right? And 9 indices, let's say it will be odd, right? Just to be on the safe side, because time, it won't cause a TLE, right? 8 or 9, using 8 and 9 won't cause a big harm to you. So always pick on the bigger side which is given to you, which is, let's say you had a 9. So at every 9 you, let's say, pick up the highest even element, which was 8, right? So it will be 72, right? And for every odd you picked the lowest value, which is 9 into 1, which is only 9. So the lowest value could be 72 minus 9, which is 2 and 63, yes. And there might be a case where you picked all this value and this you picked at 0, right? So 9 into 0 is 0, and you made it as 9, so you are picking all upper values, so it will be 81. So at worst case your difference array won't exceed 81, right? Still, while I was in contest, I have picked the value as 270. I don't know why at that point I thought of using 270. You could have picked any number around 80 or 100. I think 140, 150 would also do the work, right? Just to be on the safe side, I picked a number which was way too huge, so that it won't cause memory limit exceed for me, right? All right. So now what are the next step? So the base case, let's look at the base case. The base case was if index is equal to s dot length. If you have reached the length index, then if you have started, right, means you have started, and if your length is greater than 2, then if your difference is equal to 0, you return 1, else you return 0, right? I hope base case is clear, that if your length is greater than 2 and if the difference is equal to 0, then only you can return a 1. All right. All right. And then the basic memorization trick we will use, whatever the changing parameters were there, we will write all that in this DP. So it will be a big DP, right? Because my logic at that point said me to create variable multiple states, so that I don't get caught or get a wrong answer. So if it is not equal to -1, we will simply return that answer, right? All right. Now we will find the upper value, right? This is how we do the digit DP thing, right? Upper value is, let's say if your tight is equal to 1, right? Means you have a tight value, means you can't pick any number of your choice. Then at that point your upper value will be nothing but s of index minus 0. Means if it was a 7, then you can't pick a value greater than 7, right? And if your tight was equal to 0, right, then you can pick any number till 9, right? You don't have any restriction, pick any value of your choice, right? And after this, what you will do, will simply traverse from 0, I equal to 0, till the upper value, right? And do the following steps which are done in digit DP. I hope you know that, right? So you will simply create the number, right? So if tight is equal to 1, and we will check if the upper value is there or not. So if the upper value is there, we will change our tight respectively, and if it is not there, right, if tight is equal to 0, right, if tight is equal to 0, let's say, then you can pick any value, right? And if you are at even position, if I modulo 2 is equal to 0, right, then what I will do is, in the difference I will add even, right? Difference plus equal to even. And if I is equal modulo 2 is equal to 1, right, then you will subtract it, right? Simply you can do vice versa as well. It won't cause a big change to the answer, right? And that's it. That's the main solution of this problem, right? So I hope you have understood this. If you look at the code is pretty simple. I have made it very obvious, so you will understand it in a simple glance. Let's look at the code. All right, so if we look at this, so we are given what we will do. First, we have converted the string s to high, right? And we have called the solve function and finding high answer. Similarly, we will find the low answer as well, right? So low answer will be again called solved by the solve function, and the answer is high minus low. Now let's try to understand how this solve function works. That is the main crux of this problem, right? So it's very simple, right? If you know a bit about DigiDP, if you don't know, please do let me know in the comments. I will definitely make a video on that as well. So first we will create a DP of size 20, which is index. Second is type, right, of length 2, it can be 0 or 1. Then of length 2, which is started, either it will be true or false, it will be either started or not started. Length can be at max 20, it was 15, but on the safe side we have used 20. And 271, really sorry for that, the difference couldn't exceed that, it won't be that big. Still I have used a value which won't cause any issue to me in the in the contest time. So first look at the base case. This is the base case. What the base case means: the base case is simple. If you have started already and if your length is greater than 2, and if your difference is equal to 0, then only you will return a 1, else you will return 0 in every other case, right? Then the basic memorization trick: if dp of all this state is not equal to -1, you will simply return that value, right? And then you will find the upper value, right? If type is 1, then upper will be whatever the index is there. If let's say the number was 5, 6, 7, and you were at this point, if type was equal to 1, then you can't exceed 6, right? So upper is fixed. And if type is 0, then upper can be go till 9, right? So you will go from 0 to upper, right? New type will be found using this formula. So if there's type already, means if type is 1, right, and if I has reached upper, then new type will be 1, right? And if your type is already 0, right, if you don't have any restrictions, then new type will always be 0, right? And n started, if you have started is equal to 1, means you have already started, and I is not equal to 0, then new started will be 1, else new started will be 0, right? And new length is, if new started is equal to 1, means you have already started, then new length will be incremented, else new length will be 0, right? Now, if your new started is modulo 1, means you have started, and your position means the ith index which we are traversing in. So if position is equal to is at odd position, then we will simply do a difference plus I. And if you are at even position, you will do difference minus I. You can do vice versa as well. I have already made you understand. And if you have not started, new difference is already equal to difference, right? And answer is simply, answer will be answer plus equal to solve of the function, whatever the value we have found. Simply we will pass these values in the parameters, and dp of those changing state will be equal to answer, and you will return the answer, right? I hope this part is clear to you. So I have explained each and every logic of the contest which was needed. So I hope it was beneficial to you. If yes, please do like, share, and comment, and subscribe as well. Thank you for watching.